All right, let's get started, shall we? Hello, everybody. Welcome to the webinar, How to Accelerate Parametric FEA using Rescale, where we will take a look at an example of a local parametric analysis setup in Abaqus and walk through how to migrate the workflow to cloud, as well as how to automate post-processing for complex data sets and large design spaces. So lots of exciting stuff coming our way, I guess you could say. My name is Jolie Hales, and I will be your moderator today. All right, slide number 2. As we're waiting for people to trickle in, we did want to make you aware of the Big Compute podcast, which is presented by Rescale, and it often features Rescale customers. So not all of them, but many of them who are spoken to, many of the interviewees who have these cool stories to tell are actually Rescale customers. And basically the podcast shares stories about how engineers and scientists, just like you, are changing the world through computational simulation. Those IT professionals are definitely looped in there as well. And it's on top charts around the world and being hailed as the radio lab of engineering. But we do think you'd enjoy the podcast, and you can subscribe, obviously, wherever you get your podcasts, or as the ad said, at bigcompute.org. Okay, looks like we got our people in here. We can talk about Rescale a little bit more. Our presenter for today is Ryan Magruder, who is a solutions architect at Rescale. And a little bit about Ryan: he has spent his career working closely with many of the industry-leading finite element tools, providing consultation and education across several industries, and he advocates for the advantages that cloud HPC can provide to FEA users, which he will be doing for us today.
So thanks everyone for joining the webinar today on accelerating parametric FEA workloads using Rescale. As Jolie said, my name is Ryan Magruder. I'm a solutions architect here at Rescale, and what we'll be looking at today is how to easily speed up your finite element simulation workflows using the powerful HPC hardware that Rescale gives us access to. We'll start off by discussing some of the common challenges faced by design and simulation engineers and the typical applications that are well suited for FEA. And then we'll actually move on to a live demo of the Rescale ScaleX platform, where we'll take the existing parametric analysis that's already been set up for another tool, in this case Abaqus, and we'll look at how we can transition that on-premise workflow into the cloud. As a quick reminder, the webinar is being recorded too, so if you do want to catch anything, review it, it will be posted on our website later this week, and our resource center also has all of our previous recorded webinars, which are a great tool for learning about Rescale. So without further ado, let's get started today by looking at why Rescale's cloud HPC platform is a good fit for FEA workloads. And to start out, Rescale does address a lot of the issues that you're going to get with legacy on-premise hardware when trying to run FEA simulations. In terms of ownership costs, Rescale is a pay-as-you-go model, so one of the biggest challenges that we see with finite element workloads is that you're not always sure when or how much capacity you're going to need for a given project. So Rescale is great in that it allows you to dynamically allocate that hardware and kind of scale up and scale down as you need it, so that you're always going to be able to get the hardware that you need. And you can really eliminate the bottlenecks that you can get with an on-premise cluster, where you're going to spend a lot of time sitting in a queue during times of high usage. Lastly, it also removes that orchestration layer that you might need if you're a global organization. So you can really ensure that your users always have access to the latest and greatest hardware. As your FEA workloads advance and progress, you can make sure that you're always getting the hardware that's going to allow you to get your results back as fast as possible. And at Rescale, we also use a global infrastructure, so it makes us a lot more fault tolerant. It's more highly available and more reliable than on-premise clusters. So if you've ever experienced a situation, like I'm sure many of you have, where you've had a local cluster go down and you're sitting without able to do simulation resources, moving your workloads to the clouds can be a great way to avoid those and be confident that you're always going to be able to get the results back when you need them. Moving on to Rescale in particular. So what Rescale really provides is that orchestration and optimization layer. So at the moment, Rescale offers over 650 software applications that are ready to go, and they've been tested and optimized for all of the major cloud providers. So you're not limited to just the resources that a single cloud provider is going to give you. We can launch these softwares on all of them, so you get the best of both worlds, where you get the capacity and the specific actual hardware instances that these guys put out. So you're able to get the best hardware to meet the type of simulation needs that you have, and all of that is packaged up in our Rescale ScaleX platform. So that's the actual web interface that we'll be taking a look at in just a little bit later today. And it's also available through our public API, so you can actually integrate the Rescale platform into your existing application or even just your larger workflow. So with that background out of the way, let's take a look at the actual problem that we'll be looking at today. So the simulation that we'll be looking at is a crash test analysis, and crash testing, or really any kind of destructive testing, can be incredibly expensive to physically prototype, not just because of the cost and time of actually building these prototypes, obviously, but because the prototype itself can't be reused after the crash. So what a lot of engineers have done in the past, and are certainly doing today as well, is to move some of these workloads to FEA packages that provide solvers using mostly explicit methods to capture these very small timeframes that we're going to need to capture the impact, and also have the ability to simulate very nonlinear material models because of the severe damage and deformation that we get, in addition to the contact challenges that are present when we've got all these components under the hood in these cars. So building these virtual models allows us to simulate a number of testing configurations that are going to be required. So there's a lot of different crash configurations when we're testing crash worthiness in the real world. And building these virtual models is going to allow us to do all of those configurations and update our design as the actual design of the car itself is iterated on. So we don't have to build a new physical prototype, obviously, for each one of these models. So a lot of these simulations are done with a kind of a very limited set of FEA packages, including LS-DYNA and Abaqus, both of which are supported on Rescale. The example we'll be looking at today is Abaqus, but this could certainly apply to any of the other finite element tools that are out there. So our actual example for today, we can see here. So this is a, in the middle, you see the actual mesh of the model that we'll be looking at. It's just a car that's going to be doing a frontal crash into that wall there. And what we're really interested in here is parametrically changing some of the key variables in order to investigate an entire design space. So for this particular simulation, we're going to be varying the impact velocity that that car is going to hit the wall at, but we could certainly, change the orientation of it as well. And what is impacting it so that we could actually access, multiple different crash configurations. But we'll keep things simple here today, and we'll just go through and see how we can take this model, which is parametrically varied to impact the different velocities, and simulate that efficiently on Rescale. So we will be jumping right into a design of experiments workflow, which is a parametric analysis. But in general, we would usually recommend starting with a single analysis first as you get things set up before you move on to a whole sweep. So some of the options that you'll see in our interface today are kind of highlighted up there on the right, including the ability to clone the job, share it with colleagues so they can add their own input files or configurations, and then also launch a virtual desktop to visualize the results. The structure of the actual parametric analysis will look something like this down below. So we'll upload input files, we'll specify some variables that will control the sweep, and then we'll add some additional post-processing steps so that we can quickly extract the KPIs that we're interested in without having to download the full result set and interrogate it that way. So let's actually jump out of our slides here, and we will take a look at the demo. So to start off, I'm logged into the Rescale platform, and what I'll do first is just click the big Create New Job button here on the left-hand side. And this is our window for creating a new job. So we'll give it a name. We'll just call this Abaqus DOE. And the very first thing that we'll do is to actually change this from a single batch job, which is what it's set up as default, into a parametric analysis. So as I said before, we'd usually recommend starting with this, but we'll go right to a DOE. So we can change that up here in the job type, and we can switch this to DOE, which stands for Design of Experiments. And what that is going to let us do is modify some variables in our input file after uploading a parameterized input file, and then sweep over those variables to get multiple result sets back. So we'll switch over to that, and we'll see that the interface here slightly changes. So if we did have any supporting input files, we could actually upload those now. In this particular model, we don't actually have any supporting input files. We just got the model input file that will run. And so we don't need to complete that step here. So we'll jump over into our templates here. Before we do that, let's actually pause and take a look at the files that we have. So we'll switch over here to some Abaqus input files. So in Abaqus, you can actually set up parametric studies in a very similar way to how you would set them up on Rescale. You start with an input file, which is what we can see here, this e1_param.imp. And you also include a parameterization file, which is the one we were looking at before, that PSS file. So that defines how the variables are going to be changed. So if we switch back to the parameterization file, what we can see is the definition of a variable here. We can see the values that it's going to get varied between, that 6,500 and 24,000. And then we can see a number here for the number of simulations that are going to be executed between there. So what this is going to do is it's actually going to generate 8 different input files, and each one of those input files are going to have a different value for the velocity. So the velocities here are in millimeters per second, I think. So these roughly come out to about 15 miles per hour to 55 miles per hour. So those are the impact velocities that we're going to be looking at. The only modification that you need to make to the input file for an Abaqus parameterization run is to add the parameter definition here. So here we've got a placeholder for just that parameter velocity, and then you just need to actually plug it in to the actual velocity value. So here is where we're defining the initial condition. So here's the initial velocity of the whole model, and we can set that input variable using the angled brackets and the variable name. So that's how we would set it up in Abaqus. So in this case, we're looking at an example where an engineer's got a parametric analysis set up. This particular analysis would execute sequentially, and depending on the size of the model, it could be infeasible to run this locally, just because of the amount of time it would take. If we're running, much more than 8 simulations, for example, and if we did want to run them in parallel, we'd really be limited to our local hardware. So we may not have the necessary memory, or if we did divide these up, we may not have the CPUs to really solve these in an efficient manner. So what we'll do instead is take this example and do some small modifications, and we'll actually be able to run it on Rescale without too much effort at all. So to start, we're actually just going to make a copy of this input file. So let's do a quick save as on this guy. And we're just going to name this with a small appendix there. So when we change this input file to get ready for Rescale, it's actually very simple, and we do use a very similar setup here. So back up at the top, we just need to remove this parameter definition. Rescale is actually going to take care of the parameterization of the file, so we don't actually need that in the input file anymore. And then Rescale actually uses a very similar notation here for the velocity, or for the parametric variable. So all we need to do is replace those angled brackets with curly brackets and add a $sign in front there, and that's all we need to do. So what Rescale is going to do instead is it's going to take the velocity values that we'll define, and it just goes through and plugs those into the input file. It takes care of the generation of all the input files for us, and that's all you need to do. So in this case, we're looking at an Abaqus example, but this kind of substitution can be done for any input file that you're working with. That can be for an FEA package, or even something like a script, a Python script or MATLAB script that you're running on the cloud. So very powerful for our DOE examples, and that's all that we need to do with this input file to get it ready for our submission to Rescale. So we'll go ahead and switch back over to the Rescale interface here, and we'll upload that template. So this is what we call a template file. So we'll click upload. And we'll upload that to get ready. The next step, we'll actually jump back in the process here while that's uploading to parallel settings. And so this is where we can actually define the values that we're going to sweep over when we submit this simulation. So we could upload a CSV file. So this CSV file is going to contain rows of variable names and then columns of the variable values. So you can use a CSV file, if you don't want to, what we're doing here is basically just going from a min value to a max value with an increment. But if you did have more specific design points that you wanted to hit, a CSV file can be generated that just contains those very specific variable values. So we'll keep it simple again here. We'll just actually specify our variables, so we don't have to use a CSV. So what we want to get for the name is just the name of that variable that we plugged in. So this is our velocity 1. We'll give it a min value, which was the 6,500, the max value of 24,000, and our increment of 2,500, just to get those 8 simulations. Once we've added those in, we can just hit add. And there we go, we've added our variable. So we could add more, right? If we wanted to modify, say, the height of the wall that the car is going to impact, we could add that too, and it's going to do a little cross product between the two. So if we add 8 in this one and 2 wall heights, we'd get 16 total simulations, but we'll just stick with the 1 here for now. So next up, we've actually set up the whole parametric setup, at least for the input file and the parameterization. So what we need to do next is go over to the actual software selection where we'll select Abaqus. So we'll switch over to the next step here in software. You can see all the different software packages that Rescale offers, right? We'll just select Abaqus here. We can also select the version. So in addition to all the different softwares that Rescale provides, we also provide different versions of each one of them to make sure if you do have any version requirements for any kind of jobs that you're running, it's always going to meet it. The last step in the software setup is to specify the actual commands that's going to be executed. So this is the command line submission of the input file. And if you're not familiar with the command line parameters of the kind of software that you're using, Rescale does offer command templates that we've got here for most of the major software products, and we're certainly able to help you get those sorted as well. So in this case, for Abaqus, it's a very common tool. So we have a command that's populated for us. And all that we need to do is actually just plug in the name of that input file. So that was E1 param _ rescale.imp. And that's all we need to do. So it'll execute that model and it will execute the parameterized versions of it in the parallel settings there. You would also specify your licensing here. So this could be on-premise licensing. We'll just use the on-demand licensing for this example and move on to our hardware settings. And our hardware settings, we can really see how the cloud is going to allow us to accelerate this workflow, right? So not only do we have access to a wide range of core types here, but we also have access to a lot of capacity when we're running those. So if we select this Onyx core type, for example, which is a Xeon processor, we can scale this up to however many cores we need. So if this is a simulation that benefits from being massively parallel, either multi-node or just MPI with multiple CPUs, you can scale that up as much as you need. The limitations of the cloud are fairly limitless in terms of the hardware that we have available to us, so you should be able to run as much as you need access to. For this simulation, we will pick Onyx. We'll select 18 CPUs to run on, and then the option next to it called slots. This is how we actually control how many of these simulations are going to run in parallel. So when we choose 4 slots here, for example, we're going to have 4 simulations running in parallel, each with 18 cores. So for this parametric example where we have 8 different simulations, this means it's going to run the first 4 on 18 cores, and then it'll automatically transition those nodes to run any remaining simulation. So we'll go 4 by 4, and we should get our results back in the time that it would take to just run 2 of these simulations. And we could certainly bump the slots up if we wanted to, but we'll leave it there. The wall time is just going to control a timeout value, so the simulation should run pretty quickly, so we can just leave that as the default. The very last step here is post-processing. So definitely whenever we're running design of experiment studies or any kind of really big design space exploration, one of the biggest challenges that you're going to have is interrogating those results, right? It's nice to be able to generate a ton of different result files for different design points, but actually processing that data and getting the key information out of it that you want can be a bit tricky. And so one of the ways that we can easily do this in a tool like Abaqus is to actually script up some result extraction. So what we've done locally here is actually created a post-processing script, which is going to give us some key results initially. So Abaqus offers a Python-based scripting language that we can access the results from. So we've just created a short little Python script here, which is going to load up the results of our analysis, and then it's going to extract the maximum strain dissipation in that analysis. And we'll see what that allows us to do in Rescale here when the simulation completes. So we'll choose to load up that post-processing script, and then all we need to do is specify the command here to run it. So when we want to execute those scripts in Abaqus, we type Abaqus Python, and then the name of that script. And so that's all the setup that we need to do. So what Rescale is going to go through and do is it's going to take that template file that we uploaded that contains the parameterized variable. It's going to plug in different values for that variable depending on the parallel settings that we set up. It's going to run it through with Abaqus on the hardware settings that we specify, and then it's going to execute this post-processing script after the simulation completes, and it's going to give us some information out that we can take a look at. So we can hit save on that and actually submit it. I think this simulation takes about an hour to run, so we do have a completed version that we'll look at, but we can take a look here. If we do submit it, all these simulations can be tracked as they execute, so we can actually see the different steps here as it's validated, the cluster starting, and then it's running. And you can track these simulations as they go, so you can view all the output files as they're generated. You can even log into a virtual desktop, for example, and view the results as it's executing to make sure that things are progressing right. So it's not submitted into a black box. You definitely have access to these, and you can check to make sure that things are progressing as you'd expect. So as I said, we do have a completed version of this job that we can take a look at. So let's actually just go log in and look at that. So here's what the job looks like when it completes. And so if we go take a look at that status page, right, this running job ran for 54 minutes, almost an hour. And each one of those jobs, if we go and look at this results tab, we can actually see some kind of durations on them, right? So each one took about a half hour, but since we were running 4 simulations at once, we were able to get this back in under an hour, since we're going to be running those simulations in parallel. So certainly a faster way to get these large design spaces back quickly, and Rescale makes it very easily to set up and run these. What we do want to look at here though is those post-processing options. So if we take a look at that post-processing script, the last step that we'll do after actually extracting that value from our result file is to print it to the console. And what this allows us to do is to look at some of those results directly within the Rescale platform without having to load up any extra software to look at them. So in Rescale, if you do add a post-processing script, all you need to do is just print a message to the console, and that includes the variable name as well as the actual value of that variable. So what this is doing is it's just extracting the value of this string parameter at the very last step of the model, and then it's going to print it to the console. And what that lets us do is actually see that value here. So if you were just interested in the value itself, of course, it makes it very easy to kind of visualize the values. But Rescale also provides some interesting tools here where we can look at some graphs of the actual values itself. So there are different chart types that you can select between. So in a scatter plot, right, we can set the velocity on the x-axis, our values there on the y-axis. And this one is fairly linear, not quite, but it's almost there, and we can see what we'd expect, right? As the velocity increases, the strain dissipation is also going to increase as that car crashes at higher and higher speeds. For this simulation, there's only the one parameter that we extracted, but you could imagine if you'd extracted multiple, right, we can also create area plots as well. And so if we had some runs here, we can create area plots where you can get a better look. And Rescale also offers 3D surface plots. So if we add a few variables there, right, we can actually see an interactive surface plot that we can zoom around in. So these kind of tools, you can build these kind of plots in post-processing tools like MATLAB, obviously. But what we really want to do here in the cloud is give you the availability to run these large design sweeps and easily get this information back as quickly as possible. So in this case, right, we didn't have to download any results. We didn't have to do any local post-processing. We set this all up to run in the cloud so that we can easily take a look at these graphs and get the information back quickly that we need. So that's it, at least for the demo today. I hope that was informative. We have about 5 minutes left here, so I did just want to pause at the end here, and we can kind of go into a Q&A session. So if you do have any questions on anything that we covered here, or maybe how to adjust it for your own workflow, we'd be happy to answer those. So let me switch back here, and we can start to take a look at some questions.
Great, thank you so much, Ryan. It looks like we have a couple questions who have gotten in here already so far. If anybody else, as Ryan said, has any, don't be shy, feel free to write those in there. Let's see, Jason asks, do you support user subroutines?
We do actually, yeah. So we support Abaqus user subroutines. We actually have an article on them in our documentation. So if you do go to Rescale and you log into the platform, all you have to do is click the little help drop down in the top right. It's got a link to our documentation. And if you search in there, we have an article detailing how to integrate user subroutines into your Abaqus simulations. And I think it also has an example there with it. So definitely check that out. If you do have any issues finding it or questions about how to implement it, please just reach out to our support. And we can help you, but it's definitely possible, and we've got some resources to help you get that set up.
Great, thank you. Another one here from Arpita. Can you use multiple software packages together?
You definitely can, yeah. So when we went through this example, we just added the Abaqus software package, right, when we were running the simulation. But you're not limited to just one software package. You may have seen actually after I selected Abaqus, the little plus signs still stayed up there to add more software packages. So we can add additional layers onto it. So if you needed some more complex post-processing options, for example, right, if you wanted to to take the results and actually feed it through something else, you can layer multiple software packages onto each other. There's no compatibility issues with that. And so if it is a multi-tool workflow with multiple steps, you can do all of that within Rescale without having to do any extra kind of orchestration or scheduling or anything like that.
Great, and it looks like, oh, one just popped in. This one from Amir. Can you submit simulations through the GUI? the GUI.
Yeah, definitely. So the interface that we looked at today in the web, that's at least that's what we would consider the our GUI, and so that's how we can submit simulations. But we do also have an open API that I mentioned at the start, and so that API allows you to just make REST API calls and access all the features of our platform. So everything that you saw me do here today was all just based on the API calls in the background. So if it is something that you want to build into a separate application, all the functionality is there. So Rescale can kind of be the simulation backbone of whatever tool you have. So it's not directly integrated into like Abaqus specifically, the one that we looked at today. But you can run scripts in Abaqus, right? You can run Python scripts, and you can certainly access our API through Python. So it's definitely possible to build that in so that when you do submit some jobs using an Abaqus script, it's actually going to go to Rescale and solve there, and even then download the results automatically. So yeah, our API is definitely powerful and open, and can make those kind of tools accessible to you.
Thank you, Ryan. Looks like that is all our questions, so we can end our webinar here. Just a reminder that you can keep up to date on the Rescale platform by visiting any of our social channels, and you can find the Big Compute podcast at bigcompute.org, wherever you get your podcasts. So I think that's it. Ryan, thank you for your presentation. Thank you all for joining us, and have a great rest of your day, and make sure to stay safe out there.